Okay, first let's just flip back real quick. Does anybody have any questions with 9-5? Oh yeah, especially there's a couple challenge problems I want to look at. All right. Anybody have any issues? And then of course I want to talk about 35 because I thought that was an interesting problem. Anybody? Nobody has any questions with that? Tell me.
23.
Which one?
23.
All right, let's take a look at 23 real quick. The arbor shown AC and BC are tangent. The radius of the circle is 26 and EC equals 20. Find the measure. All right, so let's first draw this out. So let's do this from here to here. What did it say EC was 20? I'm gonna put a 20 there. And the radius of the circle is 26. Now, the thing is, on most standardized tests, they leave this out. So I would go ahead and just draw that in. The point of tangency is important because it forms a what?
Right angle.
Yeah, it forms a right angle. I don't like that one though. So if I draw from here to here, that looks like the point of tangency is okay. And so that's 26. Now, what you need to do then, I think, is draw this out here. And that is also what? And then we're looking for AC, right? So now the hypotenuse is how long? Did everybody see that? 46. Does that make sense now? So if I can mark that, from here to here is 46. So if this then is X, it's just going to be 26 squared plus X squared equals 46 squared. And to me, that doesn't look like a triple because that's 2 times 13 and that's 2 times 23. All right, now, and of course, AC and BC are what? Equal. Right, so that's not a big deal, no. All right, anybody else on that? Come on, guys. Nothing? Even with the challenge problem? Was anybody able to figure it out? Tell me. Good job, Mr. Varner.
So if you draw, I think it's called like an altitude or something from just to make a line that sorry, I'm just describing for you. Like
No, that's okay.
From S over to the line PR and cut off.
Yay! Look right here. That's the key. Very nice work, buddy. Very nice.
And then you have 4 and 2, and then since segments of the rectangle are each radius of the circle, you know that the line RS is 10 because it has the radius 6 and 4. And then you can just do the Pythagorean thing.
That is brilliant. Right, and I honestly tell kids all the time, especially when they're taking the SAT and ACT, if you don't have the ability to draw parts in that aren't drawn, you're just never going to get it. All right, you have to sometimes take a chance and just draw lines in. That was very difficult, actually, very difficult. You had to know to draw this perpendicular from S to PR, all right? And then, of course, now you're just using the Pythagorean theorem to find this distance right here. Everybody okay with that now? Wow, that was very, very good. All right. So draw that in if you did not. Draw that in. Nothing else. All right, kiddos. Let's knock out today's lesson. Simple, simple. Yesterday's was easy. Today is much easier, actually. All right. So now what we want to do is I'm just going to make a circle and we're going to talk. All right. Now, here's a chord and here's a chord. I'm going to call this A, I'm going to call this B, and I'm going to call this C. So, this we're going to define as arc A, and this is going to be defined as arc B. There's a relationship between the intercepted arcs and this angle. Is that a central angle, by the way? No, it's not a central angle. If it was a central angle, then it would be equal to the arc. But there's a simple relationship. The angle is A plus B divided by 2 is equal to C. All right, that's the formula for today. Right, and I just say it's the average of the arcs. The angle is the average of the arcs. All right. Now, the other thing is if you have secant lines or tangent lines, so let's just review that. So here are two secant lines because, again, they intersect. So here we can say, for example, this is X, this is Y, and this is Z. All right, now the angle I say is on the exterior of the circle, not the interior. So now, believe it or not, instead of the sum, it's the difference. So it just becomes X minus Y divided by 2 is equal to Z. All right, now technically I guess I should put those symbols up there because those are the arcs, right? So angle Z is arc X minus arc Y divided by 2. All right, and over here I should do it. Arc A plus arc B divided by 2 is equal to angle C. And that is it. All right, now I think we've already done this one, but let's just go ahead and draw another example. So if I'm going to draw a tangent line, and then I'm going to draw a secant line. Now this one's a little harder to see, but I just want to make sure, right? I'm referring to this angle right here. This is the angle that I'm referring to. So if I call this arc, let's just say W, and I call this X, what's the relationship between W and X? Angle X is what? Half of W. That's kind of like the inscribed angle, but it's not exactly inscribed. So this is the intersection of a tangent and a secant. So this is a tangent line, and this is a what? Secant. And if I call this over here Y, and I called this over here Z, this angle Z, then what's true on that one? Say it again. You agree with that? Say it again, whoever said that. Drew, what did you say? Yeah. Z is equal to 1/2 of Y. Now, how do I remember that, guys? How many degrees are in a circle? So what is arc W plus arc Y going to equal? Right? arc W plus arc Y is equal to 360 degrees. Does everybody agree with that? And X plus Z is equal to how many? 180 degrees. Does everybody see what I'm showing you? So now that was easier for me. Once I realized that, it was easier for me to remember that the angle is always half of the arc because there's more arc, right? There's 360 degrees that covers one line. All right, hopefully that makes sense. All right, but that, I believe, is all we have to know. All right. And then, like I said, that brings us to almost the end of the chapter. We just have one section left, but I'm not going to do that section. We're going to spend next week doing this last section. All right, so now let's take a look at how simple these problems are. All right, so if you're not good at mental math, get out your calculator. All right. If you want to get better at mental math, then don't get out your calculator. All righty, so I'm looking for the measure of angle 1. So the measure of angle 1, someone please tell me. How much? 110 degrees. Now remember, you're not just writing down 110 degrees. You're telling me how you got 110, right? It's just the average of the arcs. It's the average of the arcs. All right, so now how am I finding TS? Yes, thank you. That's the best way, right? Take 126, multiply it by 2, which is, of course, 252. And then we do what? Minus 108, which is? I think it's 144 degrees. 144. Is everybody good with that? Simple, simple. Everybody good? 144 degrees. All right, so angle 2, come on. Yeah, 73 degrees. All right, here we go. Now the measure of angle H. How much? Somebody said 31. Bo, how do we do that? That's all there is to it, guys. 88 minus 26 divided by 2 because the angle is where? On the exterior. All right, the angle's on the exterior, so you're going to subtract the 2 arcs and then divide by 2. All right, so now over here, I'm looking for QTS. How much? So I have several people telling me it's 248 degrees. How do we do that? Someone tell me. 71 times 2. And then you add 106. All right, now if you want, it's really X minus 106 divided by 2 equals 71. Just in case you wanted to see that. All right, but because we're good, we can just work backwards. I'm totally fine with that. Anybody have any issues? Okie doke. I need help with LP. Say it. Somebody said 150 degrees. I'm not sure if that's good. Everybody okay with that? 150? All right. Now, for some reason, let's figure out what they're saying here. A ramp is attached to the first of several barrels that have been strapped together for a circus motorcycle stunt as shown. What is the measure of the angle the ramp makes with the ground? So I guess they're asking me about this angle right here. Now, I guess what they're telling me is that this is 165. Does everybody agree with that? right? That's what I think they're referring to. That took me a second. So is it just what? How much? No, 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 no. There's no rule that says the exterior angle is half the arc. That's the interior angle. Inscribed angle is half the intercepted arc. Come on. Who said what? 15. How do we get 15? Was just decide 180 was good number? Why is it 180? Come on, man. All right, so we got a little problem here. Come on, I don't want to tell you the answer. I want someone to try to help me figure it out. Come on, think it through. All right, I'm not giving you the answer. Tell me. Well, how do I know it's half the arc? How do I know? No, it's definitely not. There's no rule that says the exterior angle is half the intercepted arc. Tell me. Yay, I knew someone was brilliant in here. Just one person. Thank you. So this right here, okay, let me get it so you can see it. So that was excellent work as usual. Here we go. So everybody draw from here to here. How many degrees is that? Stop. A lot. Tell us, Kenzie, what is it? All right, so she said this is 195 degrees right here. Okay, so now what? It's gonna be so funny. Tell me again, how do I do it now? Yeah. So again, it's kind of funny. I'm hoping it's a coincidence. Do you see now we have this formula right here where it's on the exterior, correct? Right. So it's 195 minus 165 divided by what? Divided by 2, which of course is what? 15. All right. So 180 minus 165 just happened to be what? The correct answer, but all right, that is a complete coincidence. All right. All right, that was pretty good. All right. But again, that's not always the case. All right, that's not always the case. And let me make sure that's not always the case. So what we're going to do is we're just going to change this 165. Let's just say it was 140 degrees. Then the other side would be 220. Wow. And then we subtract those. I think I might have learned something. What happens when I subtract those? Yeah, wow. Wow. So Mr. Udalis gets a big prize for today. Yeah, okay, so now what I want to do is I want to do this, guys. Look at this. All right, now I just see why it works. All right, so let's go back to this picture again. Everybody draw this on your iPad so you can figure things out. All right, now, and this is another great example of me trying to tell you, I don't have everything memorized. I think about it every time to try to see what works and what doesn't work. All right, so now we're going to try to figure out why in the world does that work. All right, so what I want to do now is I want this to be X and I want this to be Y. All right, I don't want numbers. I want to try to prove that it always works now. All right, so here's the center of my circle right here, correct? This was a point of tangency when you lean your ramp up against it. And this also was a point of tangency down here. So what happened to this angle right here and this angle right here? It forms a what? Forms right angles, correct? Now, I don't know why I didn't remember this. This right here, this angle, this angle, this angle, always have to add up to what? 360, because it is a what? It's a quadrilateral. That's correct. All right. But whoever said kite is also correct, because we know this is congruent to this, and these are both radii, so those are both equal. You agree with that? So now, if those add up to 360 and these two add up to what? 180, that means x plus y have to equal what? 180. So after all that, Mr. Udaley was correct. However, listen carefully. Does y over here, is y the same as this? Because it's a what? No, it's not an inscribed. It's a central angle, right? So because remember now, the central angle is the angle that's being created by that arc. Hopefully that made sense. All right, is everybody okay with that?
Yeah.
All right, so again, I'm trying to tell you the review, there's lots of information on the review. And I always say I think this chapter is easy because even if I forget something, I can kind of figure it out. All right, that's what I'm trying to make sure you are doing. I'm trying to show you, as Mr. Udaley showed us, that's 15 degrees. He wasn't sure why it was 15 degrees, but it was a good guess that it was 15 degrees. And I said, well, no. All right, because I wasn't thinking about that. All right, I was using what Kenzie was doing, that it was the difference of the arcs divided by 2 is equal to the exterior angle. But it just so happens now that we show if it's tangent, all right, the exterior angle plus this arc always add up to 180. All right, hopefully that makes sense. All right, and believe it or not, I did actually remember now seeing that on the SAT once. All right. So I'm happy with that. I'm trying to see if there's anything more. There's a little bit of algebra, but not much. All right, I'm pretty happy with that explanation. All right, so I feel like you guys are good with the rest of it. Now I am gonna say something, you guys. I've always said I really enjoy first period because it gives us like almost an hour a lot of times to do our work. All right, so that's what I want you doing. All right, I think y'all, the boys, are getting carried away with your whatever you're doing. All right, find something else to work on once you're done with your math. All right, and actually what I'm going to do is once you're done with this, I'm just going to go ahead and post the review. All right, so tomorrow, I think the review is like 75 or 80 questions. All right, so you can get started on that once you're done with this. All right, I also posted the solutions, right? So check your answers and make sure all the answers are correct. Anybody have any questions with today? All right, very easy lesson. All right, go ahead, get started. All right, Brady, you don't have any questions, do you? You good, Brady?
Yeah.
All right, man. You have a good day, all right?
Thank you, you too.
All right, take care, buddy. Hope you're all right.
Bye.
Bye.